rewriting cost. If it becomes obsolete, we have to replace everything. Then fourth one is dependence on external environment. Okay, if an applications depend on okay, hardware stability, it doesn't change use during the program's lifetime. No maintenance cost due to the hardware changes will be incurred. Must be changed to use new hardware that replace the obsolete equipment. So next we come to technical factors. Okay, we have module independence, programming language, programming style, program validation and testing, documentation, and configuration management. So module independent, where it is possible to change one program unit of a system without affecting other unit. So we know, right? Module unit testing. So in unit testing, we have to check only one module at a time. Likewise, in module independence, it is possible to change one program unit of a system without affecting any other unit. Programming language. So programs written in a high-level language, programming language. High-level programming can easily understand the low-level programming language. You know, the low-level programming is difficult to understand, but high-level programming language is easier to understand. So this is what they are telling in programming language. Programming style. So method in which program, what we have written in the program, which must be easily understandable and it can be modified. So in programming style, it must be easily understandable and can be modified at any time. So programming validation and testing. So it effort or spend on design validation and programming testing. Okay, if there's any error, validation in the sense, to validate the program. Testing in the sense, if there is any bug in the program, we have to rectify in the program. So coding errors are generally relatively cheap to correct because we can easily correct the errors. Design errors are more expensive as they may include the rewriting of one or more programming units. Okay, documentation, as we have already discussed. Okay, it is an important unit of project planning. So it requires program is supported by clear, complete, and concise documentation. The functions of understanding the application can be associatively straightforward. Then configuration management technique, so which is used to track of all system documents, ensuring that these are kept consistent. These concepts are coming under software cost estimation technique. Software cost estimation technique. So next we are going to discuss about software requirement definition. So IEEE definition. So what does it mean by software requirement engineering? Okay, it's a condition or capability needed by a user to solve a problem or achieve an object. A condition or capability that must be met or possessed by a system or system component to satisfy a contract, standard, specification, or other formally imposed documents. So software requirements as three types. One is functional requirements. Second one is non-functional requirements. Third one is domain requirements. Okay, these are the types of software requirements. So what does it mean by functional requirements? Okay, requirements, I mean, these requirements that end user specifically demands the basic facility that this system should offer. And these functionalities need to be necessarily incorporated into the system as part of the contract. So non-functional requirements. So it has basically deal with the following issues. So what are the issues? Portability, security, maintainability, reliability, scalability, performance, reusability, flexibility. So it is basically that the system must modify according to the project contract. So it has these many issues. So NFR is nothing but non-functional requirements are classified into the following types. So interface constraints, performance constraints, which is response time, security, storage space, etc. And the operating constraints, lifetime constraints, and economic constraints. Then next is domain requirements. So domain requirements nothing but the requirements which are characteristics of a particular category or domain of project. So next title is the software requirement specification. In short, we can say SRS. Software requirement specification is a document that captures the complete description about how the system is expected to perform. Because if we documented about a project, it must be carefully maintained, which describes about the system to be expected to perform the same. So it's usually signed off at the end of the requirement engineering phase. What are the qualities of software requirement specification? So it must be correct, unambiguous, complete, consistent, ranked for the importance or stability, verifiable, modifiable, traceable. So what are the types of requirement? One is general description. What does it mean by general function of product, which include objective of uses, user characteristics, features, benefits, about, why its importance mentioned. It also describes about the feature of user community. Second is functional requirements, okay, which include calculation, data processing, etc. are placed in a ranking order. So third is interface requirements. So it means how software program communicates with each other or user, either in form of any language. It may be any programming language. The programmer know about the software and know how to communicate with each other if they face any problem. Message or calculate, describe and explain. So example, or can be shared. So these are the example, shared memory and data streams are examples of interface requirements. Next one is performance requirements. So this is how software system perform desired function under specific condition. In interface design, which is used to communicate with each other, and we must explain about anything clearly. Okay, here performance requirements, the system performs desired function under specific condition as explained. It also explains required time, required memory, maximum error rate, etc. Then fifth one is design constraints. So which simply means limitation or restriction or specified and explained for design team. Design constraints nothing but limitation or restriction. So non-functional attributes. So here attributes are explained that are required by software system for better performance. Next is preliminary schedule and budget. So in this, initial version and budget of project plan explained, which include overall time, duration required, and overall cost required for the project development. Preliminary schedule and budget is nothing but version and budget of the project must be explained, which include time, duration, cost of the project. Okay, appendices. So additional information like reference from where information is gathered and definition of some specific terms, acronyms, abbreviation are given and explained. So I quickly revise. So yesterday we talked about
Sir,
requirement
actually,
engineering,
we could.
establishing the groundwork,
Sir, can you hear
eliciting
me?
the. Yes, I can hear you.
Actually, we could not see your screen.
See, I can not only you other. What about others? Can you see my screen? Is it visible to you all?
Yes, sir. Visible.
Okay. Okay, Tanan, you just leave the meeting and join again. You can see
Sure,
my
sure.
screen. Okay. And we have seen yesterday, I have clearly explained about these topics. One is requirement engineering. Second is establishing the groundwork. Third is eliciting requirement. Fourth is building the requirements model, validating requirements, we have clearly explained all these things yesterday and revise once again. So what does it mean by requirement engineering? Okay, this is the process of defining, documenting, and maintaining the requirements. Okay, these are the definition which cannot be changed. I'm just explaining what does it mean. Okay, it is the process of gathering and defining service provided by the system. So first we have to define, then document, then maintain the requirements. Okay, it is a process of gathering, defining services provided by the system. It has seven distinct tasks. One is inception, elicitation, elaboration, negotiation, specification, validation, and management. Okay, then next title is establishing the groundwork. So it deals with setting stakeholders and software engineer work together on the same team. So we have to conduct meaningful conversation with colleagues who are well-known members of the team. So we cannot contact with others who are not well-known. So we can communicate with the team member who are well-known. Then identifying stakeholders. Anyone who benefits in a direct or indirect way from the system which is being developed. So second is recognizing multiple viewpoints, which talks about the requirements of the system will be explored from many different points of view. Then working toward collaboration. So customer must collaborate among themselves. So we have to ask questions. The question must be context free, must focus on customer and other stakeholders, and the overall project goals and benefits. So if we want to ask questions, it must be context free, must focus on customer and the other stakeholders, the overall project goals and benefits. Without the project goals, benefits, without benefits and the goals of the project, the question should not go beyond this. So what are the example question is, okay, we have to ask question in this way. So who is behind the request for this work? Who will choose this solution? And what will the economic benefit of such solution? Is there any source for the solution that you need? Okay, next is eliciting requirement. In other ways, we can call it as requirement gathering. So elaboration, negotiation, and specification. Okay, the material I have taken from the textbook. Okay, it has I have simply given. So next is collaborative requirements gathering. Under eliciting requirements, we have lots of subtitles. First one is collaborative requirements gathering. Okay, what does it mean by requirement gathering? So meetings are conducted. So if you want to do anything, meeting must be there. It may be small group or larger group. Meeting must be conducted and attended by both software engineer other stakeholders. Okay, if you want to do any project, the software engineer and the customer, I mean the client, have to sit together and talk about the project. So meeting must be conducted and attended by both the persons. The person may be the client and the software engineer who is going to develop the software. So next is rules for preparation and participation established, and agenda is suggested that is formal to cover all the important points, but informal enough to encourage free flow of ideas. Then facilitator controls the meeting. Okay, one who is host of the meeting has the control the meeting. Then the definition mechanism is used. Okay, these all comes under collaborative requirement gathering. First is meeting must be conducted attended by the both parties. Both parties means software engineer and the client. So second is rules for preparation participation established, and agenda is suggested to cover all the important points. Facilitator can control the meeting and definition mechanism is used. Then quality function deployment, so which concentrate on maximizing customer satisfaction from the software engineering process. So if we do any project, the customer must get satisfied, then only it can be accepted by the customer. If there is no satisfaction, the process cannot be completed. Third is usage scenarios. So developers and the users can create a set of scenarios which identify a thread of usage for the system to be constructed. Fourth point is elicitation work product, which consists of statement which is a need and feasibility. Okay, a statement of need and feasibility, unbounded statement of scope for the system or product. So we have a number of lists. It consists of customer, users, and other stakeholders who participated in requirement elicitation. And description of the systems, technical environment. These all comes under elicitation work products. Then building the requirement model. Building the requirement model. So what are the elements? So elements of required model. So first is scenario-based elements. So it talks about which describes about the user's point of view using a scenario-based approach. It is described from the user's point of view using a scenario-based approach. Second is class-based elements. So each usage scenario implies a set of objects that are manipulated as an actor interacts with the system, and a collection of things that have similar attributes and common behavior. Next is behavioral elements, which affects on the design that is chosen and implementation approach that is applied. Flow-oriented elements. Information is transformed as it flows through the computer-based system. So analysis pattern which suggests solution within the application domain that can be reused when modeling many applications. So what are the subtitle comes under building the requirement model is? First is scenario based and class based elements, and third is behavioral elements, flow oriented elements, which talks about the information transformed as it flows through the computer based system. Final is analysis, which suggests solutions within the application domain that can be reused when modeling many applications. So next title is validating requirements. So how do we validate? As each element of the requirement model is created, it is examined for inconsistency, omission, and ambiguity. So if you want to validate certain things, we have to follow the questions. So to review the requirement of model, address the following questions. So one is, so is each requirement consistent with the overall objectives for the system or product? Have all the requirements have all requirements been specified at the proper level of abstraction? Is the requirement really necessary, or does it represent an add-on feature that may not be essential to the objective of the system? So we can ask these types of questions to address a model. The next question is each requirement bounded and unambiguous? Does each requirement have attribution? Does any requirement conflict with other requirements? Is each requirement achievable in the technical environment that will house the system or product? These are the questions. So next title is requirements analysis. We have already, yesterday we have discussed about these topics. So once again, I'm recalling all the concepts. So requirement analysis, which allows you elaborate on basic requirements established during the inception, elicitation, and negotiation tasks that are part of requirement gathering. And we have number of models in requirement analysis. What are they? First is scenario-based models from the point of view various system actors. Data models, the information domain for the system. Class-oriented models, which represents object-oriented classes and the manner in which classes collaborate to achieve the system requirements. Then flow-oriented models represent the functional elements of the system. Behavioral model, how the software behaves as a consequence of external events. So these are the types of model which comes under requirement analysis. Next subtitle of requirement analysis is overall objectives and philosophy. So under this, we have 3 points. One is which is used to describe what customer requires and to establish a basis for the creation of software design and to define a set of requirements that can be validated once the software is built. These are the objectives and philosophies of software requirement analysis. Analysis rules of thumb. So delay consideration of infrastructure and other non-functional models until design. So which is used to minimize the coupling throughout the system. And we have certain requirements model that provides value to all stakeholders. Keep the model as simple as it can be. So these are the analysis rules of thumb. So it must be delay consideration of infrastructure and other non-functional models until design, so which is used to minimize coupling throughout the system, and it must be a certain requirement model which is used to provide values to all stakeholders. Keep the model as simple as it can be. Domain analysis. So software domain analysis is the identification, analysis, and specification of common requirements from a specific application domain, typically for use on multiple projects within that application domain. Okay, this is a definition of domain analysis. So next is modeling approaches. So modeling approaches has different types. One is scenario-based models, class models, behavioral models, flow models. So up to this, not up to this. Next is data modeling concepts. Up to design a concept. I think modeling approaches we have already discussed. Just revised once again. So next we are going to see about data modeling concept. What does it mean by data model? What does it mean by data object? It is a representation of composite information that understood by the software. Then data attributes. Okay, what are the attributes must be there in data model? So first, name of an instance of an object, name of an instance of the data object, describe the instance, and make reference to another instance in another table. So these all comes under data attribute. Relationships. So data objects are connected to another in different ways. So it consists of two data objects. One is person and car. This is example. Okay, example of relationship. It must be connected to each other in different ways. Next is modeling strategies. Next title is modeling strategies. Here we have two types of analysis. One is structured analysis. Second one is object-oriented analysis. Now we discuss about structured analysis. It considers data and the processes that transform the data as a separate entities. Then object-oriented analysis. It focuses on the definition of classes and the manner in which they are collaborate with one another to affect customer requirements. And flow-oriented modeling. First, we have to create data model. So first level zero data flow diagram should depict the software or system as a single bundle. So primary input and output should be carefully noted. In level 0, so we should depict the software as a single bubble. Then we have to give primary input and output should be carefully noted. Then refinement should be begin by isolating candidate processes, data objects, and data stores to be represented at the next level. Fourth, honest, all arrows and bubbles should be labeled with meaningful names. Arrows and bubbles is nothing but, so from you know about data flow diagram. Data flow diagram is nothing but it talks about your whole project. So if you do any project, if you look at the DFT, we can easily understand. These are the things we are going to do. The information flow continuity must maintain from level to level, and then the level may be 2, 6, one bubble at a time to be defined. So next is a control flow model. So we have to, the creating control flow model suggests the following guidelines. So list all sensors read by the software, list all interrupt conditions, list all switches that are actuated by an operator. Next is list all data conditions. Okay, next title is control specification. So it represents the behavior of the system in two different ways, and it contains a state diagram, that is a sequential specification of the behavior, and it's also contain a program activation table and combinational specification of behavior. So it has two different ways. One is sequential specification of behavior. Second is activation table and combinational specification of behavior. Next title is process specification. So which is used to describe all flow model processes that appear at the final level of refinement. Next title is behavioral model, which indicates how software will respond to external events or stimuli. So behavioral model indicates how software will respond to external events or stimuli. To create the model, you should perform the following steps. So one is evaluate all use cases to fully understand the sequence of interaction within the system. These are the which must be followed to create a behavioral model. First, we have to evaluate all use cases to fully understand the sequence of interaction within the system. Second is identify events that drive the interaction sequence and understand how these events lead to specific objects. Third is create a sequence for each use cases. Fourth is build a state diagram for the system. Fifth is review the behavioral model to verify accuracy and consistency. These are the steps must be followed to perform behavioral models. First, we have to identify events with use cases. Okay, use case examined for points of operation, points of information exchange. We have to use case to inform, to exchange our information. Only for this purpose, we are using use case. Then state representation. The state of each class as a system performs its function. And second is the state of the system as observed from the outside as the system performs its function. So first we have to use case to exchange information. State representation is used to perform the function. Okay, that's all. We have completed the unit 2 of this software engineering. So unit 2 consists of requirement engineering, establishing the groundwork, eliciting requirements, building the requirements model, validating requirements, requirement analysis, modeling approaches, data modeling concepts, modeling strategies, flow-oriented modeling, behavior modeling. On Tuesday, I think on Tuesday, Hema madam will share all the notes in your to your WhatsApp group. There's no need to worry. I uh, I have prepared all the notes for the particular unit, which will be shared on Tuesday, I think, because I will share notes prepared by me to Hema madam. Hema madam will take care of all these things because he's the right person to do all these things. And one more thing, only 33 students have joined. Okay, inform your friends to join the session on time because it is auto recorded. If you are online for 30 minutes, it will clearly uh, displays the time the particular candidates was on this link. It will clearly show the exact time of a particular person. So I request all the students to join this session tomorrow. So the tomorrow session will be 7 to 8:30, which will be posted in your university website. You can see. So tomorrow's session will be 1:30, 1 hour 30 minutes. The session will over on Tuesday. I have prepared separate notes for MCA students as well as BCA students. So while I take the class, I have to explain about BCA syllabus as well as MCA syllabus. So in the beginning, I explained about BCA syllabus. Now I'm explaining about MCA syllabus. So we have completed Unit 2 of Software Engineering. Now we are going to start Unit 3. So in Unit 3, we have design concepts, design model, architectural design, component level design, user interface design, software configuration, the software configuration process, version control, change control, and configuration audit. These are the title comes under Unit 3 of Software Engineering. So what does it mean by software design concepts? So this is high triple definition which cannot be changed. So M.A. Jackson once said about design concept. So it is the beginning of wisdom for a software engineer is to recognize the difference between getting a program to work or getting it right. And fundamental software design concepts provide the necessary framework for getting it right. I'll repeat the definition once again. M.A. Jackson says about design concept. It is the beginning of wisdom for a software engineer is to recognize the difference between getting a program to work or getting it right. Fundamental software design concepts provide the necessary framework for getting it right. Okay, this is exact definition of design concepts. Under design concepts, we have number of subtyping. So one is abstraction, where we have two types of abstraction. One is procedural abstraction. Second one is data abstraction. So what does it mean by procedural abstraction, which refers to a sequence of instruction that have a specific and limited function. So second is data abstraction is a named collection of data that describes a data object. Okay, we have two abstraction. One is procedural, which is used to refer to sequence of instruction that have a specific and limited function. Data abstraction is a named collection of objects that describes a data object. Second is architecture. So software architecture includes the overall structure of the software and ways in which the structure provides conceptual integrity for a system. So it's a exact definition of architecture. Okay, architecture is nothing but the overall structure of the software and the ways in which the structure provides conceptual integrity for a system. So third one is patterns. So broad Appleton defines the pattern. Okay, how does he define a pattern? A pattern is a named nugget of insight which conveys the essence of a proven solution to a recurring problem within a certain context amidst competing concerns. So these are the definition which is given by an author. So fourth is separation of concerns. Separation of concerns. Separation of concern is a design concept that suggests that any complex problem can be more easily handled if it is subdivided into pieces that can each be solved or optimized independently. I repeat once again. Okay, separation of concerns is a design concept that suggests that any complex problem can be more easily handled if it is subdivided into pieces that can each be solved or optimized independently. Modularity. Fifth point is modularity. What modularity means? So modularity is a single attribute of software that allows a program to intellectually manageable. These are the exact definition which was given by an author. So I'm explaining about this the same. So this concept cannot be modified, I must say, as it is. So modules. So what are the modules? So if you look at the picture, you can clearly see. So x-axis consists of number of modules and y-axis consists of cost of effort. If cost and module increases, the cost may be increased. If cost increase, the total software cost may be increased. If module increase and cost to integrate may increase. So this is region of minimum cost. Okay, if cost and module increases, cost and module will also increase. So this is, the central point M represents region of minimum cost. These two are increment. So next title is information hiding. Information hiding. Okay, information is nothing but characterized by design decision that hides from all others. So hiding is not, hiding. You know the meaning of hiding. So information hiding is nothing but characterized by design decision that from all others. This is information hiding. So the title is functional independency. So under functional independency, we have coupling and cohesion, which is important question. Listen carefully. Okay, take a rest for some time. If you want to have a cup of tea or coffee, go and have and come back by 5 minutes.
Okay. Okay.
So take a rest for 5 minutes, have a cup of coffee or have a cup of water and come back soon. Don't leave this session. Functional independency, it is important question. Okay, under functional dependency, we have coupling and cognition. So what does it mean by coupling? Okay, coupling is an interdependence between software modules. See, clearly understand the concept of coupling. It is an interdependence between software modules. Okay, what are the types of coupling? Okay, these are the types of coupling. One is data coupling, stamp coupling, control coupling, external coupling, common coupling, content coupling. So here we have mentioned worst. So content coupling is worst, data coupling is best. So coupling is nothing but interdependence between software module. So we discuss one by one. So what is data coupling? Okay, when data of one module is passed to another module, that is called data coupling. One module is passed to another module is known as data coupling. So stamp coupling, what does it mean by stamp coupling? Two modules are stamp coupled if they communicate using composite data items such as structure and object. Do you know the difference between data coupling and stamp coupling? Data coupling is nothing but one module is passed to another module. Okay, stamp coupling, two module or stamp coupled if they communicate using composite data items such as structure and objects. So third is control coupling. So control coupling exists among two modules. If data from one module is used to direct the structure of instruction execution in another. So data module, one module is passed to another module is known as data module. But control module is nothing but exists among two modules if the data from one module is used to direct the structure of instruction execution in another. Okay. Then external, these are the definitions of coupling which can be say as it is. Say external coupling. So external coupling arises when two modules share an external imposed data format, communication protocols, or device interface. This is related to communication to external tools and devices. So common coupling, you know, if it is common, it must be in both modules. So two modules are common coupled if they share information through say some global data items. So common couples if they share information through some global data items is known as common coupling. Then content coupling exists among two modules if they share code. Here common coupling, it must share information through some global data items. If it is content coupling, it must share code. Example, branch from one module into another module. So content sharing is nothing but sharing code. So content coupling exists among two modules if they share code. Example, branch from one module into another module. Then cohesion. Cohesion is nothing but organization of different module and consistency. Organization of different module and consistency. So what are the types of cohesion available? So here is a diagram. So functional cohesion, sequence cohesion, communicational cohesion, procedural, temporal, logical, coincidental. These are the cohesion available. So first one is functional cohesion. So so functional cohesion is said to exist if the different elements of module cooperate to achieve a single function. Second is sequential cohesion. So module is said to be said a module is said to possesses sequential cohesion if the element of module from the component of sequence where the input from one component of the sequence is the input to the next. So one output component is input to the next is known as sequential cohesion, but it must proceed one after the another. It must proceed one after the another. So next is communication cohesion. A module is said to have communication cohesion if tasks of one module refer to or update the same structure. See, the task of one module refer to or update the same data structure. Example, the set of function defined on an array or a stack. Okay, if it is an array or stack, it will update the same data structure. So next is procedural cohesion. So it is a part of procedure in which particular sequence of steps has to be carried out for achieving goal. Example, algorithm for decoding a message. Procedural means we have to follow a certain procedure to do a particular thing for achieving a goal. For example, algorithm for decoding a message. So next is temporal cohesion. When a module includes functions that are associated by the fact that all the methods must be executed at the same time, the module is said to exhibit temporal cohesion. In temporal cohesion, everything must be executed at the same time. Logical cohesion. A module is said to be logically cohesive if all the elements of module performs a similar operation. Then final cohesion is coincidental cohesion. A module is said to have coincidental cohesion if it performs a set of tasks that are associated with each other very loosely, if at all. Here, a set of tasks must be performed which are associated with each other very loosely, if at all. So, what are the difference between coupling and cohesion? So, coupling is also called intermodule binding. Cohesion is called intramodule binding. So, try to understand the difference between coupling and cohesion. Coupling is also known as intermodule binding. Cohesion is also known as intramodule binding. Next, coupling shows the relationship between modules. Cohesion shows the relationship within the module. Here, coupling is between the module. Relationship is between the module. Here, relationship is within the module. Then, third point is coupling shows the relative independence between the modules. Cohesion shows the module's relative functional strength. And coupling, while creating, you should aim for low coupling, that is, dependency among modules should be less. In cohesion, while creating, you should aim for high cohesion. Here, low coupling, high cohesion, that is, cohesive component module focuses on a single function. So, with little interaction with other modules of the system. So, final difference is in coupling, modules are linked to each other module. In cohesion, module focus on single thing. Okay, these are the differences of cohesion and coupling. First, I'll try to join the meeting on time, so 2 hours over. So next title is design model. Design model. In design model, we have to explain about process dimension and abstract dimensions. First, what is process dimension, which indicates the evaluation of the design module as a design tasks are executed as part of the software process. Next, abstract dimension, which represents the level of details as each element of the analysis model is transformed into a design equivalent, then refined iteratively. So these are the definitions of process dimension and abstract dimensions. The first is data design elements. So data design elements is used to create a model of data and or information that is represented at high level of abstraction. Second is architectural design elements. So information about the application domain for the software to be built. Second is specific requirement model elements such as data flow diagram or analysis classes, relationships and collaborations for the problem at hand. Third is availability of architectural styles. So third subtopic is interface design elements. These are the elements which comes under interface design. So first one is user interface. Second is external interfaces to other systems, devices, networks, or other producers or consumers of information. Third is internal interfaces between various design components. So next title is architectural design. So what is the definition of system architecture? So system architecture of a program or computing system is a structure or structures of the system which comprise software components, the externally visible properties of those components and the relationships among them. There's a definition of exact definition of there's an exact definition of software architecture. Then representing the system in context. So under the system context, we have the architectural context diagram, superordinate systems, subordinate system, peer level system, actors. We are going to discuss one after the another. First, what is architectural context diagram? This is used to model the manner in which software interact with entities external to its boundaries. Second one is superordinate systems. The system that use target system as part of some higher level processing scheme. So subordinate system. So or subordinate system, superordinate system which focus on the higher level processing, and subordinate system which focus only on the targeted system. Okay, peer level system. So those systems that interact on a peer-to-peer basis. Actors, entities that interact with the target system by producing or consuming information. So these all comes under architectural context diagram. So defining archetypes. An archetype is a class or pattern that represents a core abstraction that is critical to the design of an architecture for the target system. How do we refine the architecture into components? So we have certain steps. One is external communication management, which is used to coordinate communication of the security function with external entities. Second is control panel processing, which is used to manage all the control panel functionality. Then detector management, which coordinates access to all detectors to the system, and alarm processing verifies and acts on all alarm conditions. So after this, the title is over. Next title is component level design. So what does it mean by component? Component is nothing but a modular building block for computer software. Component is a modular building block for computer software. So we have certain level in component level design. One is an object-oriented view. A component contains a set of collaborating classes. Each class within a component has been fully elaborated to include all attributes and operations that are relevant to its implementation. Second,
Sir, we can't hear your voice. Your voice is not clear.
can you hear now?
Yeah.
Okay, from where you can't hear my voice? From here?
Yeah, this
Okay.
point only. No.
From here, component level design.
Yes, component level. And also, would you able to provide any live example or that? So you just read the PPT, so we can't understand anything. So if you give any real time example, we can understand easily like that. That will help us. Can you give that?
Okay, it is, this
Yeah.
level, the component levels have to be explained as it is. I'm just giving an exact definitions which is given in the book.
Sorry, sir, we can't get you.
See, there is there is no example for these and the object-oriented traditional view. Just we have to understand the concepts. That's all. What does it mean by component, and what are the components available?
Okay, sir, you can continue.
Because this is theoretical subject.
Sure, sir.
Okay, if there is an example, I'll give you example. If there is no example, I have to explain about the concept clearly.
Sure, sir.
Okay, thank you. So component. I have to explain what is component. Component is a modular building block for the computer software. Okay, then.
So the software will use the one type of end of the user, right? The end user, right? So can you explain that like example of the application like that?
What application?
So we are using some application to send email to the some. We are using some application to send email, right? So like that.
See,
So sir,
Dhanan.
no issues. You can continue, sir.
Dhanan, right? Dhanan.
Yes, sir.
Dhanan.
Dhananjayan.
Okay, Dhananjayan.
Yes.
Because there is no example for these things.
Okay, sir.
Okay, it is a theoretical part. If there is an example, I'll explain you with an example. But here I cannot give an example because I have to explain what is what.
Okay, sir. Thanks.
Okay. In software cost estimation, I can give you a simple explanation according to the what to say title. But here there is no example, exact example. If there is an example, I might have mentioned here. I can explain you only the concept. There is no specific example for this. Okay, what is component is a modular building. I know because if I give explanation, it is easy to understand. Okay, but there is no example for this. Okay, only for this reason I'm explaining you only exact definition of the concepts.
Yes, sir. Got it.
Okay. Okay, component is nothing but a modular building block for software, computer software. So first one is an object oriented, second one is traditional view. So an object oriented is nothing but a component which contains a set of collaborating classes. Second is each class within a component has been fully elaborated to include all attributes and operations that are relevant to its implementation. So under traditional view, we have three components. One is control component, second is problem domain component, third is infrastructure component. So control component, which coordinates invocation of all other problem domain. Second is problem domain, which is used to implement a complete or partial function that is required by the customer. Third is infrastructure component, It is responsible for functions that support the processing required in the problem domain. So third is process-related review, which is used to create a new component based on specification derived from the requirements model. And under user interface design, we have three golden rules. One is place the user in control. Second is reduce the user's memory load. Third is makes the interface consistent. So under user interface design, we have many things to discuss. One is interface analysis and design model. A human engineer or software engineer establishes a user model. The software engineer creates a design model. The end user develops a mental image that is often called user's mental model or system perception. And the implements of the system create and system implementation model. So we have certain processes. One is interface analysis and modeling. Second is interface design. Third is interface construction. Fourth is interface validation. So these are the process of user level design. So what are the steps included in interface designs? So first of us, using information developed during interface analysis, which defines the interface objects and actions. So second step is define events that will cause the state of the user interface to change and model this behavior. Third step is depict each interface state as it will actually look to the end user. Fourth is indicate how the user interprets the state of the system from information provided through the interface. So these all comes under user interface design. Next is software configuration management. So it's a process to systematically manage this exact definition. There is an example. What does mean by software configuration? In the sense, it is a process to systematically manage, organize, and control the changes in the documents, codes, and other entities during the software development lifecycle. So next is software configuration process. It has the following steps. One is to identify all the items that collectively define the software configuration, to manage changes to one or more of these items. Third is to facilitate the construction of different versions of an application. Fourth is to ensure that the software quality is maintained as the configuration evolves over time. These are the steps which must be followed in software configuration management. Here we have, first we have to identify, then we can change the control, version control, auditing, at the end reporting. These are the steps of software configuration. First, how do we identify? So first of us, identification. So identification of objects in the software configuration, which is used to identify the basic objects. So basic object is a unit of information that create during analysis, design, code, or rest of the software configuration management. Second is version control. So version control, a project database that stores all relevant configuration objects. Second is version management capability that stores all version of a configuration object. Make facility that enables to collect all relevant configuration objects, construct a specific version of the software. So if the In a particular version, if we find any debug, so we have to make it correct and we can release in the next version. This is how we can upgrade our version. So change control, access control, and there are two types of control. One is access, second one is synchronization control. Access control governs which software engineer have the authority to access and modify a particular configuration object. Second is synchronization control, which helps to ensure that parallel changes performed by two different people don't overwrite one another. Final is configuration audit. A software configuration audit complements the technical review by assessing a configuration object for characteristics that are generally not considered during the review. So we have discussed unit 3, software engineering. So the software engineering unit 3 consists of design concepts, design module, and architectural design, component level design, user interface design, software configuration management, software configuration management process, version control, change control, and configuration audit. So these are the concepts given in unit 3. Okay, next we discuss about the software, so which was not visible yesterday. So we have the software engineering, nature of software, software process model. Under software process models, we have waterfall model, incremental process model, evolutionary process model, concurrent specialized process model, agile process, and agility principles. Okay, what does it mean by software? Okay, software is a set of instruction. So with the instruction, um, something can be run. Okay, set of instruction. We have to instruct the computer to do something. So it defines software is nothing but set of instruction which provides desired features, function, and performance. So if you give input in a particular software programming language, it gives us an output. So we have to instruct the computer to do certain things. So what are the characteristics of computer? So software is developed, engineered, not manufactured. So software cannot be manufactured. Software accessories can be manufactured, but software must be developed using a programming language. It cannot be manufactured. So software does not wear out. Okay, if you turn on the computer, it will work until you turn off the computer. So software never wear out, which means software never get tired. The third point is software is custom built. Custom built rather than assembling existing components. Custom in the sense we can modify anything. We can modify the software at any time we want. These are the some characteristics of software. So what is software engineering? So this is IEEE definition given by an author. So this application of systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is the application of engineering to software. This is the exact definition which was given by IEEE. This is the exact definition of software engineering. If you um, browse, you can get number of definition for the software engineering. Next, software engineering layers. We have different layers. First one is quality focus, process, third is method, fourth is tools. So first one is quality focus. So it's the bedrock that supports software engineering. And second is process. Process is the foundation for software engineering. Method, which provide technical how-tos for building software. Tools, which provide semi-automatic and automatic support methods. So these are the layers of software engineering. So next is nature of software process. The first is process framework. Okay, if you want to do something, first we have to frame some work. So how do we frame some work? So first we have to establish foundation for a complete software process. So if you want to do any project, the foundation must be there. What are the foundation? The foundation must consist of structure, duration, labor for the project. So foundation must be there, which is used to identify a number of framework activities applicable to all the software project. Then it includes a set of umbrella activities that are applicable across the entire software process. So this is a common framework for umbrella activities. Task set. What does it mean by task set? The task set is nothing but task set which is used to identify the work tasks that are to be completed, the work products that will be produced, and the quality assurance points that will be required, milestones that will be used to indicate the progress. So this is task set 1 and task set 2, task set 3. These all comes under umbrella activities. So how do we define a framework activity? We have Lots of process. First one is linear process. Linear process executes each framework activities in sequence. See, linear in the sense sequence. So one by one is executes. Each and every activity have to finish one after the another. So linear process flows nothing but executes each of the activities in sequence. First activity is communication. Second is planning. Third is modeling. Fourth is construction, deployment. It must be executed each activities in sequence. Deployment should not work in the beginning. Modeling should not work in second place. So act, it must be execute one after the other. So second is iterative process flow. So iterative process flow is nothing but it repeats one or more of the activities. See, communication and planning. So these are the two activities have to repeat one or more times. Then it goes to the next level. Then the modeling has to complete. Then it goes to the next level. Then construction has to finish. If there is any problem in the construction, then it goes to the communication. Then it communicates. Then plan communication plan. If there is no problem in communication and plan, then it comes to modeling. Then modeling gets over, then it comes to construction. At the end, deployment. So it repeats one or more of the activities before proceeding to the next activities. This is iterative process flow. Next is evolutionary. Evolutionary execute the activities in a circular manner. See, modeling, planning, communication, planning, modeling, construction, deployment. These are the activities have to execute circular manner. So communication, the activity starts from communication and it proceeds to the next level, planning. Then planning, once the planning is over, then it comes to modeling. Then modeling gets over, then comes to next level, then next level. Increment released. Then in this way, it will execute the activities in circular manner. Next is parallel process model. So parallel processing model, parallel is nothing but two activities can be done at a time. So executes one or more activities in parallel with other activities. So for an example, communication and planning are executed at the same time. Then communication planning gets over, it comes to the next level. Then construction and deployment will take place. According to the time, it will come to the next level. But parallelly, it has to process. So next is capability maturity model integration. So C in short we can say CMMI, capability maturity model developed by Software Engineering Institute. CMMI is used to rate the organization with different levels. I've clearly explained it tomorrow. So if you're working in a top MNC, they have certain level. According to the level, you can rate your organization. How do they rate your organization? Using CMMI level. They can rate your organization whether your organization come under level A or level B, level C. Whether your company is listed in a particular area which can be identified by CMMI level. So which was developed by Software Engineering Institute. So soft capability maturity model integration process mental model can be represented two ways. One is continuous model, second one is stage model. So under continuous model, we have capability levels. So what does it mean by capability level? An organization selects specific improvement. If there is no improvement in the organization, we cannot give them level. There must be specific improvement in the organization that best meet its business objective and minimize risk level. So if it is if a particular company achieves this object and minimize risk level, the level may be increased. According to the Software Engineering Institute, we have 6 levels. One is incomplete, second is performed, third is managed, fourth is defined, fifth is quantitatively managed, sixth is optimized CMMI. So first level is incomplete. So in this level one, there won't be any objective or goal to be performed. So incomplete in the sense nothing is known. There is no object, there is no goal to process a project. So objectives and goals of process are not known in the beginning. So this level is called incomplete. Second one is performed. In level 2, goals and objectives are well known in advance. So goals, objectives, work tasks, work products, and other activities of software process are carried out because we know about all these things. We have goals, we have objectives, and what kind of work we are going to do, and what are the products we know in the beginning of the project. So it can be performed. So next level is managed. So activities here, we can monitor all the activities of the project or product. It can be reviewed if there is any error. We can sort out the error and we can evaluate whether it is right or wrong. Can be controlled by the admin. So in managed level, activities are monitored, reviewed, evaluated, and controlled. Next level is defined. Level 4 is defined. Activities are standardized, interpreted, and documented. So once it is monitored, reviewed, evaluated by the concerned department, we have to document them properly. So next is quantitatively managed. So in this level, metrics and indicators are available to measure the process and quality. Optimized. So continuous process improvement based on quantitative feedback from the user. Okay, if there is a positive feedback, they can proceed further. If there is negative feedback from the customer, so they have to rectify the problem and improve their project. So second model is stage model. I have no clue how to improve the process of quality. In first model, continuous model, there may be goals and objectives, but in stage model, there is no clue how to improve the process of quality software. Then we have to give suggestion of what things other organizations have to be found helpful to work first. If there is no quality, we have to look other organization to improve our quality. These concepts comes under staged model. Next is software process model, under which first model is waterfall model. In other name, we can call it as classical life cycle model. We can call it as classical life cycle model. So in this model, so when we have to start a project, the requirements must know well in advance. Okay, we have to know what are the requirements or needed in the beginning of the project. So used when requirements are well understood in the beginning. If you don't know anything about the project well in advance, so we cannot include any concepts in the middle of the project at the end of the project. So all the requirements are well understood in the beginning. So second is systematic sequential approach to the software. Once we planned, it has to process sequentially. We cannot change anything. So it must be systematic sequential approach to the software development. So third is begins with customer satisfaction, customer specification of requirements. So you have to collect all the detail from the customer, then only we have to proceed. So must begin with customer specification of requirements. And waterfall model has a number of steps. First step is feasibility study. Second is requirement analysis and specification. Third is design. Fourth is coding and unit testing. Fifth is integration and system testing. Final is maintenance. Okay, these are the steps as to be carried out in waterfall model. So first is feasibility study. In feasibility study, we have to understand the problem. So for an example, we are going to get a project from a client. We have to collect all the problems for what kind of problem we are going to develop a project. Okay, if you find any project, I mean the customer says about a concept, if you don't understand about the concept, we have to make it clear from him. So we must understand the problem clearly, then we have to find solution for that problem. If you don't understand any concept of a particular project, we have to ask questions from the client and rectify on the spot. So feasibility study, in this part, we have to understand the problem and find solution for the particular problem. Second is requirement analysis and specification. To understand the exact requirement. So first we have understand the problem. After understanding problem, we can solve a particular problem. Next, what we have to do, we have to understand what are the requirements of a customer. The customer clearly explain, okay, in my project, have to do all these things. After getting all the requirements from the customer, we have to document them properly, because when we deliver project to the customer, he may say, I didn't say these things, but you have included these concepts. So at the time, if we have properly documented, we can show the proof to the customer. So for this reason, we have to understand the exact requirement of the customer and document them properly. So third step is, it consists of two different activities. Uh, One is requirement gathering analysis and requirement specification. Requirement gathering analysis, in this part, we have to gather information from the customer. What we did, we got exact requirement of customer and documented uh, his concept properly. After documenting all these things, we have to gather information from the customer, and the gathered information are analyzed. How do we analyze? We have to sit together and go through once again whether we have taken exact information from the customer or not. Okay, if there is any problem, we have to contact the client again to clarify your doubts. So second is requirement specification. Analyzed requirements are documented in software requirement specification document, and which serves the contract between development team and customers, because we have documented properly about the project detail of a client. So if there is any problem arise, we can show this document to the customer because we have already taken all the requirements from the customer. So software requirement specification document serves as a contract between development team and customers. Next is design. After getting the exact requirement and documentation, we have to analyze. The next step is we have to after documenting, we have to design to transform the requirements specified in the document into a structure. After analyzing all the things, we have to structure using a that is suitable for implementation. We have to get ready for the implementation. Fourth is code and unit testing. After doing all the necessary things, we have to um, implement. So how do we implement? Using a particular programming language, we can do a project. So coding and unit testing, what we do is in coding space, translated into source code. We have structure, so we have to translate them into source code using any suitable programming language. So we can implement any one of the programming language. So unit testing is nothing but which is used to check each model is working properly or not. How do we check? Say for an example, first model, say for an example, module one is login detail. Second one is admin module. Third is user module. First module is login module. How do we check whether the particular module is working properly or not? So using the user and password, we can verify whether the registered user is authorized by an admin or not. So first we have to check the login module. So unit testing plays an important role to check each module, to check whether each module is working properly or not. So we have to use unit testing only for this reason. Next is integration and system testing. So you know the difference between in unit testing and integration testing. Unit testing is nothing but each module can be verified. So in integration testing, so many modules have to be added, then we have to check. See, lots of modules have to be included here, then we have to verify whether it is working properly or not. Final, system testing. Here we have three types of testing. One is alpha, beta, and acceptance testing. Alpha testing, that testing should be performed by the development team. Okay, before we deliver any project to the customer, we have to verify ourselves whether it is working properly or not. So alpha testing is performed, testing is performed by the development team. And beta testing is nothing but that testing should be done by the customer, because the developer has developed the software, I mean the finished this project, the customer must test all the things is working properly or not. Then acceptance testing. The customer is verified, it is working fine. So before delivering, so after the software has been delivered, the customer is performing acceptance testing to determine whether the given project is working fine or not. So after delivering a project uh, from the development team to the customer has to verify whether it is working or not. If he finds any problem, he has to return back to the development team. The development team will test once again and deliver to the customer. So this is how system testing work. Next is maintenance, very important phase of the software development. It must be maintained. If there is any problem, we have to rectify the problem. So maintenance plays an important role of the software cycle. If you don't maintain, then software will not work. we have types of maintenance. So one is corrective maintenance, where we have to rectify errors. If there is any errors in the program, we have to correct on the spot. Then perfective maintenance, what we have to do, which is used to enhance the functionality of the system. After making all the errors, we have so the software can enhance the functionality of the system. Then adaptive maintenance. So porting the software to new environment. Okay, if you are using old environment, we can change into new environment. So these are the types of maintenance. So corrective maintenance is nothing but if there is any error in the project, we can correct the errors. So perfective maintenance in the sense, okay, after um, correcting all the errors, we can enhance the functionality of the system. And adaptive, porting the software to work in new environment. If we are using old environment, we can switch from old environment to new environment or new operating system. What are the advantage of waterfall model? It is very simple, easy to understand. Each model is clearly defined, very clear, well understood, and works well for smaller project. So what are the disadvantage of using waterfall model is, so we cannot give feedback, difficult to accommodate change requests because we have to well understand all the concepts of customer in the beginning of the project. So nothing, no place can, no changes can take place in the middle of the project. Okay, so we cannot change anything. We cannot change any reports in the middle of the project. So no feedback, no changes, no overlapping of phases. These are the advantages of waterfall model. Second one is incremental model. Okay, if there is a model, first we have to divide the model into number of modules. So how do we divide? If we want to develop a software, we might have number of modules. If we divide module, each module can be done by a software developer, or each module can be done by a particular software team. So we must divide a particular project into number of modules before we develop a software. That is the first point. So second point, each model goes through the requirement, design, implementation, and testing. Even after we divide the project into number of modules, each module consists of design, implementation, and testing phases. And the third point is every subsequent release of the module adds function to the previous release. And fourth is the process continues until the project complete the system achieved. So even if you divide into number of modules, so the project can take place up to the completion of the project. After you complete the project, it can be achieved. So this is a simple pictorial representation of incremental module where we have divided into number of modules. See, build one is nothing but module one, module two, module three, dot dot. Number of modules can be there. Even if we have number of modules and we have design and development, testing and implementation. In second level also we have design and development, testing and implementation. These are the levels. Okay, after completing a project, we can um, join together and deliver the project. So what are the advantages of using incremental model? So errors are easy to recognize because we have divided the project into number of modules. So we can easily recognize the error. So easier to test and debug. Each team can test and debug the error. Third is more complex and more flexible. Fourth point is simple to manage risk. So clients gets important functionality early. So these are the advantages. What are the disadvantages of using the incremental process model? Need for good planning. We have to plan well. So total cost is high because we have number of teams. So we have to pay for the teams because we have divided into number of modules. So to do a particular module, we have to hire lots of people. So cost will be high. Well-defined model interfaces are needed. So these are the disadvantages of incremental process model. And the evolutionary, what is it might be evolutionary process model? Software evolves over a period of time. Business and product requirement often change. So we can change the product requirement very often. If you don't like, we can change the product requirement. So evolutionary models are iterating and applicable to modern days. So evolutionary is applicable to modern day applications. So types of evolutionary models. We have three types of evolutionary models. One is prototyping, and second one is spiral model. Third is concurrent development model. So in prototype model, we have the customer must define a set of objectives, but does not identify input, output, and processing requirements. The customer has objective, but don't he cannot give input, output, and processing requirements. He doesn't know. He has only objectives. So um, developers not sure of, okay, before we develop any project, the developer are not sure about the following. What are the parameters? The developer doesn't know what kind of algorithm he is going to implement to develop the project. And adaptability of an operating system. Hello. Yeah. Hello. Is there any problem? Okay. And before, I mean, this the developer, I'm not sure of the following because the developer doesn't know what kind of algorithm he has to work, and human and machine instruction. These three things developer are not sure about. So what are the steps we have to follow in prototyping? One is we have to begin with requirement gathering. First, we have to gather information from the customer. Second one is identify whatever requirement are known. Known requirements means objective and goals must be there in your project, and outline areas where further definition is mandatory. Fourth is quick design occurred. Then fifth is quick design leads to construction of the project. If we have quickly designed, we can construct the project. And prototype is evaluated by the customer. Requirements are refined. Prototype is turned to satisfy the needs of customer. These are the steps that we have to follow in prototyping. So these are the steps. First, we have to communicate, quick plan, and quick design, build prototype. After building the prototype, we can deliver the project to the customer. Then we can communicate. Then the process goes on. First, we have to communicate, then plan, design, build a prototype, and deliver the project to the customer. These are the life cycle of prototype model. So second one is Spiral model. Spiral model initially proposed by Boehm. It is a combination of waterfall model and prototyping model, iterative prototyping model. So it includes the following components. What are the components? Communication, planning, modeling, construction, and deployments. So these are the steps of a spiral model. First, we have to identify next level stakeholders. Stakeholders nothing but client, those who are giving project to us. So we have to identify the clients first, then identify the clients with conditions. They have certain condition within this time. The cost of the project is this much, and we have to complete the project in 6 month time. So they will give you they have certain condition. In that particular condition, we have to finish the project. So we have to identify stakeholders win conditions. To reconcile the win condition, we have to establish next level objectives, constraining alternatives. Then, after developing the project, we have to evaluate the process and product alternatives and rewards risk. If there is any problem, we have to resolve the problem on this part. Then including partitions. Finally, we have to deliver the project to the customer, and they will give you review and comment. If there is any error, they will notify you. Okay, software evolves as process progress, better understanding between the developer and customer. So in spiral model, it will work in circular manner. So there must be better understanding between the developer and customer. If if the customer says something, the developer has to resolve that problem. So we need better understanding between developer and customer. The first circuit might result in development of product specification, subsequent circuit developer project, developer prototype. So what are the advantage of using spiral model? High amount of risk. Okay, if we work in circular manner, it costs more and useful for large project, not for small project. It is useful for large project. So waterfall model is useful smaller project, but spiral model useful for large and mission projects. So these are the advantage of using spiral model. So it can be costly model to use. So complete the project. Risk analysis needed a highly particular expertise. So risk can be analyzed only by the expertise, not the fresh candidate, and doesn't work well for smaller project. So this concept will work out for small because it will work only for larger project. These are the disadvantage of using spiral model. So next is concurrent models. So concurrent model is also known as concurrent engineering. Okay, which is a series of framework activities, software engineering action, task, and associated states. So all activities exist concurrently, reside different states. So we have different types of states, so which is applicable to all types of state, all types of software development, even generate even generated at one point in the process triggers transition among the states. Then specialized process model. Under specialized process model, we have three concepts. One is component-based development, which incorporates many of the characteristics of spiral model. Component component-based model has component, many characteristics of spiral model. An iterative approach to the creation of software component can be designed as either conventional software model or object-oriented classes or packages of classes. So, what are the steps we have to follow in component-based development? Are so available component-based products are researched and evaluated for the application domain in question, and component integration issues are considered. Third is software architecture designed to accommodate the components. Fourth is components are integrated into architecture. Fifth is comprehensive testing is conducted to ensure proper functionality. So these are the steps must be followed in component-based development. So the next is formal method models. So formal method model enables you to specify, develop, and verify computer-based system by applying rigorous mathematical notation. So formal method model is also known as software engineering. It has couple of disadvantages. So time consuming, expensive, difficult to use. Final is aspect-oriented software development. So there's a definition of aspect-oriented software development. So it is related to new software engineering paradigm that provides a process and methodological approach for defining, specifying, designing, and constructing aspects. This is the exact definition of aspect-oriented software development. Next is agile process. Okay, I mean the username and password will, I mean your username will automatically register. Okay, even if you send here your what is it, register number and name, I cannot note it down because it will automatically registered. So I cannot register your name along with your register number. It is okay. There is no problem. Prince Praveen will register in the attendance. If you have given your register number in last name, that will register because some of the candidates, see, Anbarasan has given his name with his register number, that will register as it is. If you have given only your name, there is no problem because attendance is auto generated. After the meeting gets over, I mean, it will exactly show the particular time. Okay, Prince Praveen was in the meeting these many hours. It will automatically display, there's no need to worry. So next title is Agile Process. So it is based on iterative model because we have already discussed about interactive development model is based on the same. Agile methods breaks task into smoother iterations and parts do not directly involve long-term planning. So each iteration is considered as short-term frame. So because it is basically work on the principle of iterative development, each iteration is considered as a short-time frame. So each iteration helps to minimize the project risk and reduce the overall project delivery time requirement. So Agile as life cycle, which includes planning, requirement analysis, designing, and coding and testing. These are the life cycle of Agile process. And we have certain phases in Agile. So one is requirement gathering and design the requirements and construction and iteration. Fourth is the testing and quality assurance. Fifth is deployment. These are the phases which have to include in agile process. And agile testing methods have um, Scrum, Crystal, and dynamic software development method, and feature-driven development, lean software development, extreme programming. So first one is Scrum. So what does it mean by Scrum? Scrum is used to manage tasks in team-based development condition. And second is we have Scrum as the roles and responsibility. We have Scrum Master, Product Owner, Scrum Team. Okay, what is the role of Scrum Master? Scrum Master can set up the master team, arrange a meeting, remove obstacles for the process. So Scrum Master can arrange meeting if there is any problem. He can rectify the problem and make the meeting to go in a good manner. Second is product owner. He has attained responsibility. He can product backlogs, prioritize the delay, and responsible for distribution of functionality and each repetition. So Scrum team. So Scrum team can manage its work and organizes the work to complete the cycle. These are the roles and responsibility of Scrum. Second is programming. So extreme programming is used when customers are constantly changing demands and requirements when they are not sure about the system performance. So the customer doesn't know what the requirements. So in this case, we can use extreme programming to change demands and requirements. So third is Crystal. There are three concepts of this method. One is chartering, second is cyclic delivery, third is wrap up. So what does it mean by chartering? Chartering, making development team performing feasibility analysis and developing plans. So using chartering, we can do all these things. And cyclic delivery, under this, we have to cycle. It consists of team updates and team updates release plan, integrating product deliveries to users, and wrap up. This phase performs deployment and force development. Force deployment. These two things can be done in parallel. So fourth is dynamic software development method. So next is dynamic software development method. So which is used for the software development, gives agile process distribution. So dynamic software development method, it can be used for software development and gives agile project distribution structure. And user must be actively connected and have the right communication. We have techniques in dynamic software development method. One is time boxing, Moscow rules, prototyping. And DSD project contains 7 stages. One is pre-project, feasibility, business study, functional model iteration, design iteration, implementation, post-project. Success feature-driven development. Feature-driven development focus on designing and building features. Next is lean software development. It follows the principle just-in-time production. It indicates the increasing speed of the software development and reducing costs. So lean software development follows the principle just-in-time, which is used to increase the software, the speed of the software development and reduce costs. So phase eliminating waste, amplifying learning, default commitment, early delivery, empowering the team, building integrity, optimize the all. So, what are the advantage of using this model? Frequent delivery, face-to-face communication with clients, anytime changes are acceptable. It reduces total development team. What are the disadvantages of using DSDM? It creates confusion and critical decision. Maintenance of finished project can become a difficulty. So last is agility principles. We have 12 principles. We have to learn as it is, and we have to learn as it is. You should not change anything in this principle. First principle is our highest priority is to satisfy the customer through early and continuous delivery of valuable software. Second, welcome changing requirements. Even late in development, agile processes harness change for the customer's competitive advantage. Third principle is deliver working software frequently from a couple of weeks to a couple of months with a preference to the shorter time scale. Fourth principle is business people and developers must work together daily through the project. Next is build projects and around motivated individuals, give them the environment and support they need, and trust them to get job done. Sixth is most efficient and effective method for conveying information to and within a development team is to face-to-face conversation. Seven is working in software is a primary measure of progress. Agile processes promote sustainable development. Practice developers and users to be able to maintain a constant pace indefinitely. Continuous attention to technical excellence and good design enhance agility. 10, 10 principle is simplicity, the art of maximizing the amount of work not done is essential. 11th is the best architectures, requirements, and design emerge from self-organizing teams. At last principle is at regular intervals, the team reflects on how to become more effective, then tunes and adjusts its behavior accordingly. These are the two principles of agility. So far we have discussed software engineering, nature of software, software process models, waterfall model, incremental process models, evolutionary process models, concurrent models, specialized process models, agility process, and agility principles. So tomorrow we discuss the man spec W5 principle, process and project, software measurement, software project estimation, decommission technique, project scheduling, risk management, identification, project projection, refinement, or triple plan. We discuss tomorrow. So try to um, try to be in the class on time because it is automatically recorded. Inform your friends to join this session tomorrow at 7 to 8:30. Okay, thank you. Notes can be shared at the end of the day from the concerned person.